Welcome everybody to Women in AI Hackathon 2023. This is our final technical workshop. These technical workshops aim to provide you the closer look and understanding to different topics from our expert speakers. And with that, I would like to welcome everyone to an insightful journey into the future as we explore the fascinating world of generative AI technologies and applications with Professor Mayy. Let me introduce her. Mayy is a software engineering technology artificial intelligence professor at Centennial College. She currently holds the position of artificial intelligence program coordinator at the college. She has practical hands-on experience in developing machine learning models, natural language processing models, and big data recommendation systems. Mayy has developed and delivered courses in the areas of natural language processing, recommender systems, machine learning, big data, and predictive analytics at universities and colleges around Canada. Her research work has been published in the IEEE Transactions on Software Engineering Journal. She has also presented and published conference papers at the IEEE Big Data, the Data Mining Software Repositories, and the International Conference of Software Engineering, ICSE. Her practical 20+ years of experience covers the banking, telecommunication, and academic industries. She has led many projects in the field of business intelligence, CRM, geomarketing research, and channel migration across several countries worldwide. Mayy continues to support data analytic initiatives in organizations with the focus on maximizing the value obtained from data by building analytical models that relate to data and business processes with the objective of providing information for key decisions. We encourage participants to ask questions in the chat and take advantage of this lovely session, which is about generative AI technologies and applications. Over to you, Professor Mayy.
Hello, everyone. How's everyone doing? Here, I'm very happy to meet all the participants in the hackathon. Hopefully, I will be able to add a little bit to your current knowledge about generative AI. It's a field that has recently, like in the past 5 years, just boomed. So I'd like to start by talking about what we're going to talk about today is some applications and use cases. Talk about the core technologies, like what enables generative AI. We'll give a focus on large language models, and we'll talk about some risks and challenges. According to MIT, recent report, they're saying the top 10 technologies that are disruptive, meaning that they are game changers. And on the top of the list was generative AI. So I don't know if any of you have heard of Jasper. No. So this is a small article from Wall Street Journal. And Dave, who is the CEO of Jasper, was a guy who was trying to build a business for, maybe he failed 6 times, but then in 1 year, he brought together all his marketing knowledge, the people who work with him, the IT developers, and they built a company. They built a product called Jasper, and the purpose of this product was to help businesses in their marketing efforts. So the growth over 1 year ended up, so his revenue for the first year ended up to be $35 million. And he got more and more round seeds. And in 1 year, the valuation of his company is $1 billion. And that was all enabled by getting into generative AI. If you look at our friends in Meta, they consider generative AI as pushing the creative expression. Why? Because it generates new content. If you look at IBM, their definition of generative AI, it's a class of machine learning technology that allows us to generate new data from training data. So this new content can be either text, can be images, can be videos, and they built their companies around sophisticated, pre-trained models like GPT-3, GPT-4, Bloom. We're going to talk about these models, and so AI is fascinating, and I'm not saying it's not. But traditional AI in our algorithms, we always used to look for patterns in the data, and the output was either a pattern or a prediction, a very powerful prediction. Like, for example, the email in your mailbox, is it a spam or is it a ham? That's a prediction. So when we look at it from the point of view of generative AI, it's a form of artificial intelligence, but the output is not just a pattern or prediction. It uses machine learning. It uses deep learning, similar to traditional AI, but the output is a content. And usually this output comes out because the end user gives a prompt, gives a question. And based on it, this new content shows up. So also in our world of AI, we always look at algorithms as discriminative AI or generative AI. Now, the main difference is in the first, we do a mapping between the input variables and the target output. While in generative AI, we focus more not to compute a score or a label, but rather generate new data. And vectors that relate to the original data, but they are randomly generated. So probability theory, there's a heavy load of probabilities in. Now, all AI involves probability, but in generative AIs, it's more. So let's talk about use cases. I don't know if you're aware, but generative AI has been key in code generation, like programming. And we're going to see how many products are out there and use cases for it. In the legal domain, in customer service, sales and marketing, product development, presentations, and even more. So let's talk about the first area, which is auto code generation. Now, if we look at this statistic that the US Bureau of Labor forecasts 26% increase in the number of technical jobs in the next 10 years. And that amounts in the US to about 370,000 jobs. Worldwide, we're talking about 4 million jobs. And bottom line, you need talent to be a developer, right? Now, usually you do that by training or studying, or there are new tools these days which help you do no code, low code. And our friend generative AI has shown up on the horizon. So, for example, this tweet or on X talks about a developer who has started using a product from Microsoft called Copilot. Copilot, I think I have a spelling mistake here, but what he's saying, it's hard for me to go back to manual coding, still learning how to use it, but it writes 80% of my code at 80% of accuracy. I don't really code. I prompt and edit. So how does it work? As a software developer, usually they would be developing in an integrated development environment like Visual Studio, Visual Code, and generative AI for coding. It's possible because of these large language models that use deep learning algorithms, and they are trained on vast data sets of existing source code. How many in here have heard of GitHub? Can we see that on the chat? Yes? Crystal, Nahed? Look, yeah, that's great. How many have not heard of GitHub? That's okay. So we all know what's on GitHub. What's on GitHub is code. Code in very, like you write your code, you host it up there, and these models, these companies have used certain deep learning algorithms to access that data and build models. So when I talk about an LLM, I'm talking about two parts really, which is one represents the natural language understanding that the model learns from the data. And the second part is a language generator. So what our programmer does, he enters a plain text prompt describing what they want the code to do. So you can tell it, hey, I want you to build a website with light color scheme that has 2 drop. And generative AI can suggest the code or the full function. It also can do another thing. That is, you all know that there's many languages out there. So there's Java, Python, C#, C++. You can provide it with a Python script and tell it, please translate it into a JavaScript. So these are a few of the companies or the products out there that are that do autocode generation. There's Copilot X, AlphaCode, Tabine, Magic, Polycoder, Blaze. I'll talk about 3 of them. So Copilot X, it's owned by Microsoft. They had it first. They had it as a product that they used internally. It was called Codex to generate code. And Microsoft, because they invested in OpenAI, they took that product and extended it to integrated development environments like their Visual Studio Code. Now, they make money of it. So for individuals, it's $10 per month or $100 per year. Now, Copilot X is based on a GPT-4 model. They conducted a survey that included 2,000 developers, and what they found was 60 to 75% of the users said Copilot made them feel more fulfilled about their jobs and less frustrated. And another fact, 73% said that Copilot helped them stay in the flow of development, and 90% said that Copilot helped them complete their task faster. And this is an area where it's been debated. Will generative AI take over my job? So please interrupt me if you have any other questions. Another product out there is AlphaCode, released by DeepMind in 2022, and this uses an encoder decoder transformer architecture, which we're going to talk about in the next section. Some clustering algorithms. The difference here is the data they use to train the model. So they used GitHub, and they used 715 used code from contests. Like this contest you're in. So if you're writing code and hosting it, I don't know if they did any agreements, but they use like Kaggle contests. And they were using their product to compete in contests. Isn't that cool? Sabine was one of the first AI code generation in 2017. Now the difference is, instead of building one big model, what these guys did is they built a model per language. So there's a model to generate Python, there's another model to generate Java, etc., etc. Oops, sorry. Another field is legal. And we all know that legal depends a lot on text, right? So the product Do Not Pay, also the robot lawyer. One of the first entering the AI code generation category because of the data. They have a lot of structured data. So they use generative AI to automate the process for canceling subscriptions, receiving refunds, filling claims. But then came a really interesting application in 2023. Do Not Pay was prepared to use its technology as a lawyer. And they scoped it for traffic court cases. Just if you get, you might need to have a lawyer to help you out. So they developed it in a way that the AI could hear and understand the people in the courtroom, and it could advise the defendant what to say, and they would be wearing headphones. So this is the idea that came out this year. Unfortunately, there were a lot of people who were not happy with this idea because that would cause a lot of people to lose some jobs. So the guy backed off on robot lawyer, but the technology is there. Do we have any questions, or shall I continue?
Please continue, Professor. We are keeping the questions in the chat for the later. Yeah.
Okay. So sales and marketing is and customer service, they interact. And the main idea here is, for retail, it's always been that we treat retail as a segment of people. There wasn't that personalization aspect. So they would personalize if you're a VIP, but not as a part of a big segment. And generative AI in these models tended to be able to show a lot of personalization and creativity. Remember, in sales and marketing, you always have to be creative and create content. So one of the products is AnyWord, and they use it to generate messaging briefs, suggest article topics, build outlines, research summary, improve existing copies. Now, that's not one, but there was many other companies. So Jasper was one that I talked about at the beginning. There's also Ink, and Ink's main business case was to get high rankings in. So they used GANs, which we're going to talk, and transformers and reinforcement learning to build that. Regi AI was focused on solving the problem of content creation for salespeople. And here they could personalize. Cresta helps sales and service, sorry for that, helps sales and service organizations to communicate with their customers. So this company is focused on using generative AI to improve search engine optimization and streamline the consulting process. Writer is another product in generative AI to assess in writing. So another area that nobody would think that they're using generative AI for is product development. So there's a product called Spoke AI. What it focuses on is generative AI will help solve the problem of deluge or a lot of information for many applications. What happens in large companies, there's always a lot of systems. Minimum, there's 10 systems. And information gets scattered across these systems. So the product from this company was focused on a language task that summarizes everything that comes out from these systems. So they relied on existing large language models like GPT-3, GPT-J, and Bloom. And the company has created its own to do some semantic search and named entity recognition, which is another NLP task, natural language and question and answer identification. It had to create its own because these tasks are really vertical industry focused. So the general speech that you will find on the internet might not be the terminology that a pharmaceutical institute is using. But they built that in addition to the general ones. And they built a generative knowledge base. They raised 2.1 million. Another company, Zappy, is helping in developing prototypes. Presentation, I think you've all heard of Tommy. So this app launched in 2021, and it's the fastest productivity app to reach 1 million users. Excels in storytelling. Actually, if I'm not mistaken, the owners of this are the creators of the original PowerPoint that Microsoft bought. The system doesn't just generate text, it generates text and images, and it relies a lot on AI systems from OpenAI, such as the GPT 3.5 and Dale 8.2. And they just recently had another series of funding. So generative AI refers to a class, and let's talk about these technologies that are underlying all of this, the models, large language models or image models. The real technology can be summarized in 2 words: deep learning. Now, the first, and I'm going to talk about this technology that showed up, is called GANs, Generative Adversarial Networks. Then the transformers. So these two are key enablers for everything you see in generative AI. There's also variation encoders and diffusion models. So I'm going to just start with GANs. And actually, it is, you can imagine it, that we will create 2 neural networks that fight each other. Jan LeCun is one of the most famous professors and doctors in AI. They said his words were, "This is the most interesting idea in the last 10 years in machine learning." And the guy who introduced it is Ian Goodfellow in 2014. So basically, if you look at this image, we have 2 neural networks. One of them, we'll name it generator network, and the other, the green one, I'm going to name it the discriminator network. Let me move this a little bit up. Okay. So let's start with the discriminator network. And one of the interesting things about this is the idea that you don't need labeled data to build. So you can say, I want to create a system that will generate animals with 4 legs. So we can get many pictures of animals with 4 legs, and I think all of them that I got have 4 legs. And we pass them to this guy, the discriminator network. And the nature of deep learning is when you pass a lot of stuff, similar stuff, and you have a lot of hidden layers, this network will learn those features. Okay? So that's one part. Once we do that, and this guy's learned the features he should be looking for, what will happen is we start giving the green guy a real image from the training data and a fake image generated by the blue guy. And we ask this guy, hey, can you distinguish between these two? Of course, at the beginning, if I give him the rabbit and the empty frame, you will say, yeah, this is fake. Through back propagation and loss functions, the generator learns that, oh, I need to be more clever. So maybe he produces an image with 2 legs, okay? And they go to the green guy, let's say a horse or a unicorn and a birdie, which is fake immediately, the bird. Until they reach a point, maybe the dinosaur, it's got 4 legs, it's not showing the 4th, that this guy reaches a point where he says, oh, this is a 50-50 chance. I can't distinguish the real from fake. And in that case, we finish learning this network, and this generator would be a trained network that can generate these fake, that can generate for you new images of animals with 4 legs. So they are fighting, and that's why we say competing and fighting. Usually the networks are convolutional neural networks, and it's a game between these two during training until, and we call it, it's a zero-sum game, until this guy says, I give up, I cannot distinguish fake from not fake. So out of this idea, deepfakes showed up as an app. Now, building on this idea from 2014, types of networks started evolving, but all of it have the same idea. So cycle gang, which would take in, you can train a network to give you a different variation. So you give it a horse and it'll give you a zebra with different patterns. Or we could call the discogram. And this has not one generator, I think two generators, but it will be able to grasp the concept to generate data based on cross-domain relationships. Also text to image and image to text. And this is a little bit more complicated, but the idea of generating data, that's what's in it. The second technology that I'd like to touch on very quickly is called the transformer technology. And this was an idea that came out from Google AI researchers. Originally, there was in deep learning, there was encoder decoder, but they took it to the next level. And LLMs depend on this technology to learn language and to respond in natural language. So there is two components, an encoder, which is helpful if you want to classify text, applications like sentiment analysis. An example of an LLM that uses an encoder only is called BERT. We're going to talk about this. And this is for when you want to generate text, the decoder part. So it takes input from the encoder and come up with new text. Now, transformers were not just for text. You can use them for many use cases, understanding interactions of prescription drugs, finding anomalies for fraud detection, deriving meaning from huge legal documents, creating digital twins for proteins. Mustafa Suleyman, who is the co-founder of DeepMind, said, in the context of text, that if you think about it, most the information in the world has a sort of sequential structure, and each piece of data in some way related to data that has come in the past. And a big picture of what makes us intelligent is that we can learn as humans, abstract these representations of a series of things that happened in the past well enough so that we can reason over the elements. In some sense, that is what transformers do. They take sequential data, build a good model of that data to learn an abstract representation, and then they use that to try to predict what's going to happen next. So just looking at the I'm going to talk about text representation, talk about large language models. But there are, so where I put circles, positional encoding is where, because data is sequential, we need to know the position of these sequences. And imagine how huge your data, but still this model does know the position of each word. In addition to something called multi-head attention, that will help us go beyond understanding context of just one word. And that's what makes them understand language. So I'm going to get into large language models, and I'm looking at the time. They are truly revolutionary. And we're not just talking about ChatGPT or GPT models. we've got many models out there, and this is just a snapshot. So we've got BERT, Cohere, which is here in Canada, Bloom, the Hugging Faces one, Dolly, introduced by Databricks, GPT SW3, which is China and Sweden, AI21 Labs introduces models, and Megatron, Turing natural language generation model, which is actually produced by Nevada, who are a chip provider. So I'll talk about three of them very quick. So like I said at the beginning, an LLM, large language model, is really, let me move this a little bit higher. Yeah, is really two parts. And think of the blue part is is the training part that companies like OpenAI or Nevada do one time on large, massive amounts of data. And the second part is a natural language generation. For the first part, the input is text, and we have to represent that text. So embeddings shows up as a very good word. And how many of you have heard the word embedding? Could you put it on the chat? Yeah, now that's great. We've got a lot of people who know about word embedding. Okay, so I'll just go over it for the rest. And this really, underneath it is this technology. Now, the other part is to generate the language, and what drives it is a prompt from the user. So on OpenAI, you'd be asking a question. That would be considered the prompt. And now, how can it output? It can output back a chat with a like Chat GPT, or the output could be a summarization, like the guys we saw in the product development, or we can use retrieval augmented generation to control some of the risks that I'm going to talk about, or summarization. So how do we represent text? Text is words, right? So for images, we usually do pixels. For voice, we usually convert it from analog to digital and then into numerical vectors. But for text, we have, how do we change this tweet into something that the computer could understand? Well, we've got four options here, which are basic vectorization approaches like one-hot like coding, term frequency, inverse frequency, which were great and working great for the past 10, 15. They generate a lot of sparse data, and that eats up a lot of memory and computing power. So there's another group of options. One of them is called the distributed representation, which focuses on context. And it does use neural networks to create dense dimensional representation of text. I'm getting so many emails. Okay. So text data, we transform it into mathematical numerical forms, into something called vectors. So each word will be a vector, a boy, a girl, this is a car. A sentence can be a vector, and this is a mathematical space. So where does this distributed, where does word embedding? So word embedding are a type of a word representation that allows words with similar meaning to have similar representation. And what I mean by similar representation is that mathematical vector that has numbers. Well, if I have an apple and an orange, which are similar because they have the apple and orange are fruits, okay? The numbers of those vectors will be close, okay? And this gets learned through a simple neural network. So behind the distribution process, and this, we're talking about 1956, before I was born, yay. Words that have similar context will have similar meaning. So when you say, I bought a blouse, most likely the word in the middle could be a large size blouse, a red blouse. So if we give this neural network many sentences from Wikipedia, from websites, from H&M websites, let's say from retailers who's Old Navy who sell clothes, Zara, and we train that neural network, it will pick up using a few algorithms, one of them SIBO, the other skipgram. It will pick up that pattern and can come up with those dense vectors. So what Google guys found interesting is once we get those word embeddings, if I would take king minus man plus woman, it would show him a queen. So we can do math on these data sets. Another example, we just measure the difference. So I'm just going to talk about 3 of these large language models. Of course, we have to talk about generative pre-trained model, which is GPT, which ChatGPT builds on. And it was an amazing phenomenon. November 30th, 2022, 1 week, 1 million signups. Facebook, it had 10 months to reach this important milestone. By January, like from November to January, how many months is that? December, like 1 month, 100 million monthly users. TikTok needed 9 months to reach this figure. So they started in 2018. Model was pre-trained using only the decoder part. So they didn't look at the encoder. And guess why the decoder? Because the decoder is the part that generates the text. So instead of the encoder feeding it, it was prompts coming in it. In 2019, they announced GPT-2. So the first model, it was a small model. And this was roughly 1.5 billion parameters. The data set had more than 8 million documents. And basically it came from Reddit. It's not open to the public out of fear. They did not open it because at that point of time, there was a lot of fear and that people might misuse it. It might be weaponized. So this one kept within OpenAI. To 2020, GPT-3. This model was 175 billion parameters trained over 5 major data sets. And OpenAI made it open to the public, and an API was made available. So that's not ChatGPT. In 2023, after that, they announced, let me just double check this. Yeah, in 2022, they built ChatGPT on top of GPT-3 and 3.5. I didn't mention 3.5. In 2023, just this year, they introduced the GPT-4 model. And what's different in this model, it generates not just text, it actually generates images and text. And they have an API for it. Another language model that we have to acknowledge is called BERT, and introduced by Google in 2018, it's open source. It was pre-trained on all of Wikipedia in addition to the Brown corpus. And it uses bidirectional and sophisticated attention techniques. Now, just based on this model, for example, the Allen Institute for Artificial Intelligence used BERT to take grade school science tests. And it proved to be very powerful. Patent BERT. Some researchers, they patents. So when you are creative and create a new product and then you apply for a patent. So it was trained and used over 2 million US patents to classify, which is a complex process. And if we think about BERT, I think it was on the encoder side, not the decoder side. BioBERT. This was introduced as a text mining for biomedical data. Another model that I thought to bring to you is called Dolly, introduced by Databricks, the guys who created Spark. It's a small model, 6 billion parameters. And the way they marketed that, companies can build their own proprietary models without sending sensitive data through an API. And that is something that why some businesses are worried to use the API, because it means whatever question you're asking goes to the API and goes to OpenAI, and they can save it, although they've changed their privacy rules recently. And it's open source. So it's cheap to build models around it. It's actually built, the Dolly's built on a model that was created by Eleuther AI. Another language model that I like to talk about is called Bloom. This, I think most of you have heard of Hugging Faces. In 2022, there was a project called Big Science by Hugging Face. And the model has 176 billion parameters. And just notice this number, 170 days were required to train this model. And the good thing about this model, it included 46 languages, different languages across the world, and 13 programming languages. And from here, you can see how models learn to code. But to run this, they needed, like OpenAI, they run their stuff on Microsoft Cloud. Here, the French government supported them by giving them access to Gen Z supercomputers. The last
Professor,
topic is challenge.
Professor, sorry to interrupt you. We have around 8 minutes left. Just wanted to remind you. Thank you.
Yeah, I know. So I'm saying the last topic is going to be risks and challenges. So size and quality of the data is a big challenge. Computation power, not many options out there to build these models. We need to use parallelization, we need to use GPUs, and data has bias, and this touches on ethical AI. So risks of generative AI models. First risk is hallucination. They tend to make stuff up. So this is, if anybody was following CTV News, we had an election in Ontario, and what do you see wrong with this image? So it was the campaign of Anthony Furey, and he generated all his literature, and by mistake, this lady ended up with 3 arms. The second risk is prompt injection into large language models. And these are attacks that would exploit vulnerabilities in language models. They were pointed out by many in the field. So um, they could fool, let's say they could fool the system. Copyright violation because of this data that we are using. I'll give you an example. Recently, a lawsuit on Midjourney was filed because of an author of a book generating the images for the book using Gen AI. Another lawsuit on Copilot because they thought that they violated the general licenses agreements of products like Apache. So copyright's another risk. Another risk, tools tend to form themselves into the conversation as affirmative in nature. So they tune the sense to use user conversation, making user believe that they are on the user side. And this is a problem. Unfortunately, I don't know if anybody read this. It was in Europe. Somebody took his life because of an AI chatbot, and that was in Euro News. Last, potential risks. It hasn't happened, but reverse engineering is a potential risk. Data poisoning is another potential risk. The more these models are embedded in critical systems, the more we are at risk. And I'm done. Thank you.
Thank you, Professor, for this amazing talk. I'm sure we all learned a lot from your detailed and engaging explanation. We all learned about GANs, transformers, LLMs, and I would like to give the opportunity to the participants to ask the questions in the chat.
Yeah.
I'll start with a question that I already see in the chat. It's from Riddhi. She asks, hello, Professor. Thank you for the presentation. I was wondering if you have come across any cool Gen AI use case that directly helpful in education or for educators.
Yes, there are. There are, but I don't know, like I don't know top of my head the product, but it is, oh, we just presented one. Just a minute, let me check. So when they, on BERT, if you remember when I talked on BERT, one of the companies, Allen Institute for Artificial Intelligence, to take grade school science tests. So they trained, the training data set had over 100,000 multiple choice exam questions. The ones that had diagrams were excluded. The model they named it Aristo, the product, and it was able to score over 90% of exams. So that's one, but there is a lot in, I'm sure, I know that there's a lot being done in education.
Thank you for answering that. I'm pretty sure Riddhi would and others would find it useful. I have a question. How much trust can now you're here, so taking advantage of it. How much trust can be placed in generative AI technologies when it comes to providing mental health support? Yeah, that's.
Well, you saw the risk.
Yeah.
You saw the risk. Like that chatbot, that Belgian man was using this AI chatbot to talk about global warming, and he the chatbot was so convincing that he suggested that the man take his life, and he did it. I worry about that, but there's a lot that can be done around it. There is prompt engineering, there is RAG. So a lot of people have found the dangers, and tools are being made available for people to use. Okay. But mental health, just be careful. Okay.
Yeah, thank you. Yeah, I understand it's a sensitive field to explore, and
Yeah.
with Gen AI being very new to to the common man, yeah, it can
Yeah.
be tough. We have another question. How
We
can
have,
one identify? Yes, yes, please.
yeah, I can see raised hands also.
Yeah. Let me let me ask this question and unmute them. How
Yeah.
can one identify whether an LLM or a traditional algorithm is enough for a use case? Any particular guideline?
Yes. So first you go to your use case. Like, let's say it is pharmaceutical. Look at the terminology that is used, like names of medicines, like, and then in that case, you would need an LLM, but you'd need to fine-tune that LLM by additional database around it, you know? So LLMs are good, or getting that data set that has the terminology. For example, airlines, they have a well-known data set called ATIS that all chatbots, any airline, Air Canada, but use it to train a chatbot. So you can use an LLM with ATIS to serve a small airline company, let's say.
Thank you for that, Professor. I see raise hands, Mina and Nahid. Would you like to put your question in the chat, or would you like to ask, unmute yourself?
Hello, can I ask my question?
Yeah, go ahead.
Hello, thank you so much for your presentation. So, about the legal stuff, about the legal stuff, I've heard so many, use cases of generative AI about, what we discussed earlier about, the mental health consultation, about the medical chatbots, about, prioritizing, and about I had not heard about the legal, but I wonder if there's any chance of them being used in critical systems anytime soon, because we know that they hallucinate a lot. We talked about hallucination, and we know they hallucinate.
Yeah.
We know use cases in court that a lawyer, even a human
Yeah.
in the loop, created this, and they, in their defense, they actually the large language model, I think, hallucinated a court case that never existed, and you said it's the affirmation bias. So the large language, they try to stay on your side and try to please you
Yeah.
somehow. So I wonder if there's any, if there can ever, if any, be used in something that's so critical, like people's lives are in, or huge amounts of financial, or I don't know, health loss can be at stake.
Now, I don't think so, Nina. I would say in the near future, in the future, yes. Now in legal, let's look at, but this is the whole point. If you have to scope into scope your use case. So paralegal, we have a lot of people doing paralegal. If you sit down with these people, like 99% of the work is really the same, right? I can see a very strong use case there to help them, right? In
Yes,
building,
exactly. Yes.
yeah, I can see a use case
Especially
there.
there are discussions about keeping human in the loop. So there must
Yeah,
always be a human to supervise it,
of
but
course.
that's also defies the the some of the advantages of the
I can
usages
tell
of
you, yeah,
large language models, right?
right. I can tell you, I have a neighbor. She works in accounts receivable. Got nothing to do with So she was looking for a job. She moved into our neighborhood recently, and she just got a job close to our house. She after 1 week, I said, "How are you?" She said, great. And I told her, how's work? And she said, great. We have 3 bots. And I said, what? They have 3 bots. And she was so excited. She's still doing. So what happens is the 3 bots are doing all 80% of the work because they're reconciling invoices for them. But if the bot is not sure, he sends the case to her. And I was surprised. I was really surprised.
Yes, thank you very much. That was great. Thank you.
Thank you, Professor Nahid. Would you like to ask your question now? And just to let you know, we are exceeding the time. We are already 5 minutes over. Go ahead,
Okay.
Nahid.
Thank you so much, Professor, for your insightful presentation. Well, I'm already familiar with some of the math behind the traditional AI models, and now I wanted to know, is it more valuable to actually understand the math behind the generative AI models, or is it better to focus on understanding the practical applications? Yeah.
It depends on what you're doing. I mean, like, what would you be doing?
Just, for example, to
Like, are
use
you
this
trying
model.
to train, to use a pre-trained model? You don't need the maths. But to train a model from scratch on enormous data sets, in that case, yeah, get into the math, but don't get too deep.
Okay, thank you so much. Also, I wanted to know if you know some other user-friendly sources that you would recommend to start with learning these models.
I can, like, there are, the good thing is a lot of books are coming out, and I love books. And I love books that have GitHub code on, so that you can use that. I can send Pretty a couple of recommended books, and she can share. Is that good?
That would be great. Thank you so much.
You're welcome.
Thank you, Professor. And I'm pretty sure everybody loved and learned a lot from this session. We are going to release this recording on YouTube. Everybody feel free to check out at your convenient time. We have all the recordings there. With this session, we conclude our technical workshop for Women in AI 2023 Hackathon. Thank you, Professor, again for making out this time coming to the panel and answering everybody's questions. I'm pretty sure everybody, other people have more questions, but we are running out of time. So yeah, everybody feel free to reach out to me or other hackathon organizers. Regarding the Women in AI, the generative AI resources, once I receive from Professor, I would love to share with you. Just feel free to email me. If somebody wants to learn generative AI through the online courses, Google has come up with pretty cool generative AI courses, and they are free to enroll. So please check them out as well. And yeah, with that, we'll conclude this session. Thank you so much, Professor, and everybody.
Thank you.
Thank you.
Bye. Bye, everyone,
Thank you so much,
and good luck.
Professor.